All right, today is February 21st. This is the bi-weekly Kepler meeting. I will let Sam to get started with the benchmark test. Please go ahead.
Huanmin, could you check if I'm able to share the screen?
Okay, let me see.
Current hint is host need to allow me.
Yeah, you should be
permission.
able to share now.
Okay. Okay. I'm going to share my desktop. Everyone see my desktop now? Is GitHub?
Yes, correct.
Okay.
It.
So let's do something with code. So for today, just in quick, I hope within 10 minutes or a quarter. Just first about the usage and the second about the to-do list and to-do item. So first is about code. For today is just about code level benchmarking. To run it is very easily. So just something like here. So go test which bench and the folder to run the code, and it's going to have the CPU information and memory information based on your version. So I just to go to run the test quickly, and blah blah blah. We can see the code later, but for next, so it's very simple as highlighted in the documentation. So it will bring you to a local server by the command there. So it's generally like I remember Michelle raised another PR and the feature to collect, those kind of file with runtime things. So we can do graph, we can do paragraph, we can do things, etc., etc. So same tool and the same format as profile. And from the code design currently, let me show you one of them. So from the code, just one for sample, we already added for some. So currently it's just to a general function input as testing and the number of the metrics. So currently we just cover the critical parts, which means the controller and the controller will have some functions like in loop to update the power consumption in matrix, and each matrix is actually, if we deeper in code, is a matrix container matrix map with is a map with some pointer, and actually it's just prepare some random data here and make it report everything and make the timer reset and do the function, also invoke the function being tested. So this is the unit some reusable function, and for detail for each benchmark. So it's here for the number of the, or say the size or length of the map, how many pointers there in the map, and something like that. So basically all the things, if possible, use the mock. Oops. Yeah, maybe we can correct the template. Thanks. And where am I? Okay. So currently, so those functions mostly just calculate the number itself. So if we go say here, so some most of time we do some number calculation, something, yeah, like this. There are no IO here. And that's current design and the usage, something. So following next for the to-do one, yeah, this ticket 506. I'm going to pause it. And so currently we have for eBPF matrix, for C group matrix, for Kubernetes matrix, for node energy matrix maybe as the critical path, and we currently got stuck with C group and Kubernetes. Because currently our some unit test means to test with C group and Kubernetes, we need to mount some file there. I'm going to show you where's the file. Yeah, here. So a lot of file related with C group. Currently, I don't want to, for benchmark testing, there are only single lines. So I don't want to thousands of lines here. So I still, I'm not deep dive into it, but I suppose we need to find out some way to mock it to avoid lines, thousands of lines appears in our code for test data. So that's all for today. Any comments, question, free talk?
Just a quick question. So when we get these benchmark test results, can we use this for example, regression test? If anything goes, we add a new feature, add new functions. Would the benchmark tell us if the new features will cause some of the performance trouble?
Uh, uh, it depends, Huamin. So there are two parts. Because currently our logic is just edit the value of the matrix. So if we go to see this matrix, there are a lot of maps there, and currently our critical path just to update the value of that matrix. So ideally, it's not too much workload there. And so that's the first thing, as something negative blocking us to make it as benchmark for our release. And ideally, from the definition of, or say from the benchmark running, how it's running. So yes, if we have a same machine there, or say same instance for running this benchmark, if we're adding some code with bad performance, the benchmark will change.
Mhm.
So is that make sense?
Yeah. So Christopher also mentioned, is this already in the CI?
Yeah, it's already in the CI, if I'm right. So our CI make file including what's the test? Where is the test? Yeah, including test which branch.
Oh, okay, that sounds good.
Yeah, but remember, CI environment is randomly agent or randomly instance, so probably we
Yep.
could not realize CI data as a reference for benchmark officially, but maybe we can just take as a reference. Should I collect but not fail test because conversion. For today it's just a code level, so
Okay.
yeah, I'm trying to reply Meryl in the chart group. So as here we have another one for Kubernetes level, and there's a good discussion and sample opened as an issue here with some test benchmark tool. Those tooling create workload at Kubernetes, but I'm not started. Okay, just share you with some information, and if anyone can volunteer to take a look at the implementation, that will be great.
Okay. That sounds good. We can start from there.
Yeah,
Yeah.
I think I mentioned before I create a benchmark tool, and sorry, I didn't create a PR yet, but I will do this week. So to receive feedbacks on that, because I'm using for my evaluations, and the tool is to generate different scenarios, run different, stress and GLP. It will be easy to add new workloads and run a lot of different scenarios. That what I'm using. So I will share that. So it might be useful for this also.
That's great.
What I mentioned here, about the performance is because, it's not easy to get performance values. Because as, some mentioned, we have, shared VM, so each runs will be very, very different from another. But it's definitely nice to collect this. And I don't know what's the best way, but we should track that somehow. Maybe not for each PR, but like for some daily information, how the performance goes, and I understand that now it's something very specific to a code path, but it's still like something good, to check. And then we can keep tracking for regression, as Kwame mentioned before.
Yeah, I do agree. So one thing I want to take this time to highlight is that our test coverage is less than half for now. So call for test case contribution. So I'm going to share another topic. So once this tool named Steelbit from the case principle, and so far it renamed to the tape as some benchmark tooling for blockchain. Another Golang project I'm contribute with. And one of the best practices is that we have benchmark pre-package level, as you can see. I'm trying to find one. Here we have benchmark per package level, and we also have some benchmark tooling related test at the CI level, because for this project, it is able to run both client and server side at GitHub Action. But for Kepler, well, let's see how many pod we can running on GitHub Action for test.
Yeah, it sounds very good. Before, just I have a question for the previous topic. So we have this, results here. Do you have any conclusion about that? Like, I know that this is hard to answer, but
Okay.
are we okay, or is something that it's like some
Okay.
performance highlight? Yeah.
Yeah, I got your point. So currently you can see from here, so it's 1000, double, nearly double, and nearly double again. So we can see here for the average time for each operator. So well, it double, nearly double, and nearly double again, and nearly double again linear, because our size is a linear, and we do in a loop, right? Loop kind of work. So the time cost, increase in a linear way. So that's as expected. So I'm good with that. And for here, the memory usage per operator. So currently with this testing, we just modify the memory, the data, so it is nearly zero. Well, I'm good with that. And because they are atomic operators, so the CPU allocations or memory allocations, something like that, nearly zero. Well, understand it, and I'm good with that. But just remember, so this kind of things is out of our, IO works, which means it's out. We didn't test Kepler fetch data from eBPF or C group, etc. things yet. We just covered our sorry, critical parts for data calculation, which means okay, we already get data from eBPF and we want to refresh those data. And I just copied the mock data from unit test. So currently we don't have a lot of randomly data. So imagine if we adding the randomly, we're going slower, or say those number will increase. Perhaps, okay. Yeah.
Yeah, I think this is very good, and maybe something that might be interesting is also to be possible to collect some similar data, but for our real execution of Kepler, as you were mentioning. For example, because we can run benchmarks to specific things to try to stress specific functions. But if we are able, to collect the same data from these functions that you are testing, but running Kepler, the real Kepler, and then we can compare things, it might be also nice, just to compare apples with apples, so we get the same data from the real execution as well.
Yeah, so maybe for next, I hope we can think about to create some mock with random and reuse those functions for both benchmark testing and unit testing. So for unit test, we can maybe just return 0 or 1 as a easy data. And for random, for benchmark testing, we can make a random, because logically benchmark testing don't need to change the, don't need to do the verification for the, otherwise the benchmark testing will do the duplication works as unit testing. We don't want to do that, right? Okay. Hello?
Yeah.
Yeah.
It sounds very, very good. Yeah.
Yeah.
This
So
Peng Hui.
currently, yeah, Peng Hui, go ahead.
Yeah, I have one question regarding to the result. The first you can get the coverage. The second one you can get the performance. What kind of performance can we get besides the elapsed time? Can we get more metrics about the performance?
Currently, you can see here, I make the benchmark things, report all the metrics as possible, as much as possible. If you want to get more, there another alternative with Lingo there. With Lingo, you can do, or say we can do some mock code. I'm going to mock the code for today because for today I didn't want to do that. So within Lingo, our test framework, we can do a timer. We start and do invoke test code. Sorry, I'm going to move the chart box. Yeah.
No worry. Oh, I can see.
And assert the and manage start within blah blah second. Some seconds. Yeah, so there's as another alternative
Okay.
a single
Okay.
round or many round testing. I suppose currently is also workable because currently we just do a round loop.
Okay. I see. Thank you.
Yeah.
Sounds great.
Mhm.
Yeah.
Yeah, so again, just we shouldn't be too strict for time, execution time, because this might vary a lot on CI. So we need to be careful, otherwise we have like a lot of flake tests.
Yeah, I suppose the most effective way for us is that we run the benchmark and you know, with some commands there to get the profile and do some investigation about why, about the reason when some performance issue happens, right?
Yeah. So can we maybe have some, as I was mentioning, like some history? For example, we don't need to have a history of everything here, but if we can, I don't know, store somewhere information about the general, performance so that we can, track. I don't know, we need to think about that. Just saying, for example, just a very, very, rough example here. It takes in average, 1 second to process everything that we want. And then we keep tracking that, for days or for months. And then we can have some idea, how the performance is moving with the code updates. But for doing that, we need somewhere to store this information. Don't know if we can have some database somewhere or where we can
Anyway,
store this information. So,
okay, for this one, I have a question. So we can maybe further discuss this offline because at 9:30 I have another session to jump to. So Meryl, my question is that imagine we have Kepler currently version as 0.4, right? And we are doing as well, I don't want to save that. And here is my my point. So, for example, we have a release for Kepler as 0.4 and another release in progress as 0.5 alpha. So, the first question, because the performance result, some benchmark result is based on the instance, which means if you check out the code and running on your instance, your result for here for the second is probably different with me. So the really things helpful in my point of view at local, we should do something like git checkout release 0.4, run a round of benchmarking here, and maybe rename the file to CPU release 0.4, no, not point, double point, and check out for another branch because we release based on the branch, right? So, oops, and do our performance today again, and maybe leave from here to here. So that's my opinion, supposed to compare the performance moving between code.
yeah, it's just because this takes like some big time to analyze, isn't it? Because a small variation will appears in the GIF, and um, I think this is good also for deep diving, okay? But I was just seeing something more simple, for example, the the biggest, path, critical path, we get only this value, the performance of the critical path, and then we just report that, something very simple that someone can just check. And if we highlight some problem, then definitely we go for deep diving, doing the thing that you were mentioning.
Okay, but in that case, the major problem is that we don't run our CI on a dedicated server, which means each time we got a different GitHub agent, and how we decouple our test case with the influence of the agent. So, for example, as
We
my
can check
experiment,
that, isn't it?
yeah. So, for example, some some operator running very fast at my local Mac, and when I'm running CI for GitHub Action, it's running, I would say, slowly about 1/3. So, for example, my locally some operator like OPS per, this is my local, and for GitHub it may be like this. So about 1/3, slowly.
So I think it's fine if slower system get have lower performance. It just need to be consistent. So the thing that we need to check is every time that we run on GitHub, if it gets similar issue values.
It's a range here, so
Yeah,
we need to
and then we
guess.
can, what's the biggest range? And then we always get the worst case in it. And then we report the worst case because this would be more fair. And then we check that, so it should be fine. At least for this analysis, maybe in the future we might have some dedicated cluster for that, but for now I think should be fine.
I think it's worth to further discussion offline via GitHub, and let's do something to have a try first. Okay.
Great. So we can follow this up on the GitHub. Thank you.
Yeah.
Next, Kai, are you here?
Yeah, I'm here.
Okay, would you mind just go ahead and start?
Oh, wait. I'm just gonna share my screen right now.
Do you want to go to the slideshow? It's on the right
Yeah,
top.
how do I? I kind
go
of
to the right.
forgot.
On the right top of the. It's not in the menu.
Oh,
right.
sorry, my bad.
Okay.
I'm not too familiar.
Sorry. I'm going to jump to another session, so I will check GitHub issue and the Slack message. See you next time.
Thank you, Sam.
Oh, thank you. So I'm just going to go over the new pipeline that we've tried to add to the Kepler model server. So the main purpose of the presentation is try to go over how get a general idea of how the Kepler model server is structured, since it's been a little bit of a black box, and then introduce this new pipeline, which is extreme gradient boosting regression model pipeline. So just to get a quick overview of like the original models of the Kepler model server. So probably the oldest model was the linear regression Keras models we set up for the predicting core and DRAM, and then those use the counter features in the CPU architecture. The Keras model by default is capable of like online learning. So you can reload a model and then you can just fit it. with new training data, and it will continue the training. The second model that we have is gradient boosting regression models, which isn't the same as XGBoost. Specifically, that this one uses the scikit-sklearn library, and we use this for predicting package power. Uses counter features, cgroup features, and specifically the sklearn doesn't implement the partial fit API, which basically means that if it doesn't implement the partial fit method, it's not capable of online learning. So we've been just using the initial models for that. And the reason why we decided to use gradient boosting regression models and also the motivation for XGBoost models is to address any data that's nonlinear. So some of the changes, so the ultimate change we made to the Kepler model server would be to introduce the extreme gradient boosting regression models, which is it's faster, has better performance. In general, it's less likely to overfit, and it produces more accurate models than scikit's just gradient boosting regression models. And not only that, the most important part about the XGBoost models that are implemented by the XGBoost library is that it's capable of online learning, unlike the scikit gradient boosting regression models. And this can be done by just reloading a previously saved model. So you can just check if there's already a model, an XGBoost model with the relevant, with the correct features and labels. You check if that's already been saved. You can reload that, continue training, and then save it, and then you can repeat. And so you can continuously train it. And some of the features that we want to, the different types of models that we want to implement for it would be would use features like counter features, cgroup features, and hierarchy features, and these will be used to predict package power. In this example, I've set up already the pipeline for the standalone model, which uses the 3 IRQ features to predict package power, and I'll go over that more in the demo. There's a quick demo at the end. So just a big overview of the XGBoost standalone model pipeline. So we have when it's deployed, we have a online trainer which instantiates the XGBoost regression standalone pipeline. It passes in essentially a type of evaluating the model. So in this case, I used k-fold cross validation, which I'll go into more detail afterwards. But you pass in the type of evaluation you want to use for your model, pass in its save location, and then in an infinite loop, you train the model. You call the train method and pass it to Prometheus client, so it can retrieve the metrics from Kepler's Prometheus. And then it'll sleep for a certain amount of time, and then it'll once again train and call the most recent or latest set of metrics that can be used for the training data frame. When you call train, that's using the that'll call the init function in the XGBoost regression standalone pipeline class, and that's present in the pipe.py. So what happens there is that it'll take the Prometheus client, it'll use that to scrape all of the relevant Kepler or all the available most up-to-date Kepler metrics that are being exported by Kepler on the cluster. It'll then use extractor.py to produce a training data frame, which will contain the IRQ metrics and the total package power. So there's going to be multiple package powers. For now, we're just going to sum that all up into one column, which will be total package power, and that'll represent the label for the model. And then it'll generate the XGBoost model by calling or instantiating the XGBoost regression model generation pipeline. It'll pass in the features, it'll pass in the labels, save location, and then the XGBoost regression model generation pipeline will be the one that actually creates the XGBoost model. So if an XGBoost model with the same features and labels already exist, it'll load that it'll load that, and if it's available, and then it'll train this model given the training data frame, and it'll either train from scratch if the model doesn't exist, or it'll sort of refit the model if it does exist. It'll then evaluate the XGBoost model and then save it. And this model can then be exposed with Flask routes. So anyone who wants to use it for prediction can pass in essentially a list of floats, which will represent each of the features, and it'll return the predicted label. So it's
what do you mean by evaluate? Is it retrain?
No, yeah. So by evaluate, it's there are different ways of doing it. In fact, actually, there's one instance where you actually evaluate the model first before you actually fit it. When you evaluate, XGBoost provides a function where, in this case, if you're doing k-fold cross validation, it'll clone, it'll create a copy of the model. It'll then split the training data frame into sort of k slices. So if you decide k to be 3, you can split into 3 slices. It'll take each one of the slices. It'll take k-1 of the slices to fit the cloned model, and then it'll take one of the remaining slices to then test it. So when it tests it, it'll pass in it'll pass in the the features. It'll receive predicted values, and then when it evaluates, it then compares the predicted values with your actual values. And in doing, yeah, sorry.
Got it. Yeah, thank you.
Yeah, right. And the important part is this is made separate from your model, so it doesn't mess up your model. But that's just one way. So in that case, in the case of the k-fold cross validation, it essentially evaluates first, and then you have to fit it, and then you can make real predictions with your model. But the traditional way of doing it, there's another way of doing it, which is a lot simpler, which is you would basically split that training data frame into train and test data frames. So you would probably, the training data frame would be like 80% of the original data, and then the test data frame would be like 20% of it. You would fit the model first with the training data frame, and then you would you would basically predict using the features from your testing data frame, and then you would compare your predicted labels with the actual labels. So in that case, you actually fit first and then you evaluate. But I'll go over that more. But evaluate, essentially, you can get a lot of error metrics that way, so you can sort of see how good your model is. You can get MSE, you can get MAE, you can get RMSE, and by looking over that, you can sort of get an idea of how well or how poor your model is. But once it does that, you can then use Flask routes to make predictions. So like I said, for the first evaluation method, probably the easiest one you can do is you do a train test split. It's also probably the worst one you can do. It's the lazy option. You would slice a random section of the training data set to be used for testing, and then the remaining will be then fitted in the model. And then you would you take the model, you would predict on the features of your testing data frame to get your predicted label, and then you would compare that with the actual label value to get your MAE or RMSE metrics. In this case, X would represent the IRQ metrics, and then Y would represent the total package power. This has obviously very high variance. It's a lot faster and it's a lot easier to implement. It has high variance because if you were to run this multiple times, you would probably get very, very different error metrics, because you're only taking one tiny slice of the data set, and then you would use that to get your metrics. And if you did it again, you can get completely different. Your test data set could be completely different than before, and you can get a completely different result. So the other option is you would use k-fold cross-validation score. So you would slice the data set into k pieces. K minus one of those pieces will be fitted on a copied model, and the remaining piece will then be used for testing. You would repeat this k times, which each of the one time for each of the slices gets to be at the testing data set. And you would then be able to, in doing this, return your a mean MAE. So you'd probably get something more that is, you get a error metric which is doesn't have very high variance because it's the mean result for each of the it's the mean result for each of the k pieces. And if you want to make it even more less variable, if you want to decrease the variance even more, you can actually use repeated k-fold cross-validation, which is shown here. And here you would just specify a number of repetitions you want to do, and each time you repeat, you would randomize all of the data again. And this is pretty, so a common problem I encountered beforehand with this is how would this actually, if you already have a model that exists and you want to evaluate how well your model does with this new data, instead of sort of doing it all from scratch, the cross-validation score actually allows you to do this. So all you have to do is you have to include, you just have to fit an additional argument, which is a file path to your model. And in doing so, you essentially will, it'll fit that model, it'll train that model continuously. And so when you then perform the cross-validation score, you get to do it on a fully trained model, which isn't trained from scratch with new data. It's trained with the new data plus all of the, I guess, its memories of the previous training. So this is probably the recommended way of doing it. It'll return the mean MAE, which is going to be less, it'll be much more accurate than if you were to do it with a train test split, and it'll have lower variance. It is quite a bit slower, but you get more accurate results. Oh, okay. And so here's just a sort of a quick demo of how the pipeline works. So in essence, you have Kepler deployed, and then let me just open this up.
Hey, do you mind making it bigger?
Yeah, I
font?
I think I have to open it.
I mean the terminal.
Right. I need to.
Oh, okay. You are actually on YouTube. Got
Yeah,
it.
I'm going to try to wait. Let me just. Yeah. Okay. Very nice. I'm just going
Okay,
to
so
open it. So I can go
while
through
you are open this, I will ask a question. You know, regarding the validation, I understand that you know, you have a data set and then you remove some inputs from the data set for the validation later. So, but can we considering, you know, how easy can we actually has two different data sets, and then we use one for training, another one for validation, and we might use different workloads for the validation, you know, changing workloads parameters and changing CPU frequency, for example, you know, just to change the environment for having a very different data set for validation, you know, just to verify and avoid overfitting. How easy is to, you know, I mean, you know, perform the validation with a completely new data set?
Sorry, are you asking if this would be or is this like are you recommending we do that, or is this sort of a question of what happens in that scenario?
I think we should support that, you know, a way to do that.
Oh.
That's
Yeah, that's So in essence, you're basically making it so that you're guaranteeing that the data is not going to be too similar. So it's going to be very, very or
Yes.
quite different, so that you can check if it's overfitting in case of that.
Mm-hmm. You know, if we cannot do that right now, you know, use different data set, I think we should think a way maybe in the future to do that. So we can easily, you know, validate, you know, the model with different data set. I mean, we can just train, for example, we have a training phase. We have a specific set of workloads that we run with specific environment configuration, CPU frequency, and then we train the model. Later on, I want to run another batch of workloads that I change. For example, we have stress energy CPU, and stress energy CPU has a lot of different algorithms. So we use one kind of algorithm to training and another kind of algorithms to validation. That's what I'm saying. I mean, just want to change a little bit things. And then when I do the validation phase, I understand that what the thing that you are showing is how the model works, how you train the model. It's always has some validation using the data that it's already there. But I think we should have also, you know, another phase that it's we can trigger some validation by collecting new workload, you know, new data, and check how things are going.
Right. No, I agree. I think that's actually a really good idea. The original idea, I should probably mention, of the model server is that the point of the online training portion, right, where you have fitting and then you have the validation part or the testing part. The point of it is so that users, when they deploy the model server in Kepler on their own cluster, that in essence the model server becomes provides better models for them. And so in a sense, it's sort of it's kind of random. It just sits there. Whatever data it can get, whatever data it's exposed to, it'll then take a portion of that to validate, take a portion of that to fit. In theory, you could get, I guess, a lot of overfitting if you get really unlucky, and I mean, even then, it shouldn't happen, right? Because this is sort of you train these models slowly over a very long period of time. So I feel like I'm pretty sure, in theory, then overfitting shouldn't happen, because at some point you're going to keep getting more and more different, or at some point you're going to get very different results, right?
You know, it's actually depends on the workloads, isn't it? So, for example, it's something that we have been discussing on Kepler, you know, a long time, internally actually. But anyway, so there is like some offline and online training. So, and the online training can be, you know, controlled by the system administrator or not. I mean, it can be trained with the user workload, or we have some initial phase, training phase, that we run a set of benchmarks that we know that we will stress everything that we will need and want, and then we create the model. So, but if we control the workload, then you are right. It will converge to at least something that we expect. But if we just leave for the user workload, it will maybe never, you know, converge to what we need. For example, change the CPU frequency. You know, if it's low, medium, high frequency, it's something that we can just running randomly user workloads. We cannot really check that if something will really runs on lower frequency suddenly or not, you know. Also different kind of workload that stress different components, things like that. We can never guarantee that user workloads will stress that. So then there is no way to guarantee that we are not going to overfit for training. And that's what I'm saying. So of course, we can also always recommend just training phase, you know, run the workloads that we select, but we also need to somehow, you know, validate that. later, as I mentioned, with a different set of workloads, different conditions that we train just to provide some information about that.
Right. Yeah, I agree with that. But not only just validate, it should also train the model too, because over time, an issue with online training is that the models can endure something called catastrophic forgetting, I think it's called, where if it just keeps getting fed with a lot of specific kind of data, it starts to forget, or it gets tuned to the point where it can't really predict. It basically starts overfitting. So yeah, so not only just validate, but I think it also makes sense to also include to train it occasionally as well. So I should probably just show the demo now then. Can you guys see?
Yes.
Yes.
Thanks.
Okay. So essentially Kepler is running in the background. I run the online trainer for the standalone model. It begins training. You can see that the features are listed here. The IRQ features are here, and the low package power is the label. And then if we can, so some of the information is stored. So once it's finished training, the first phase, it'll save the model and also save a JSON file, which includes some important information about the model. So it'll include the label name, it'll include the IRQ metrics, the feature names, as you can see here. And the purpose of that is just to make sure that when just so when we do the new XGBoost model, we don't want to accidentally or accidentally overwrite or train a model which has completely different features, right? A completely different feature on accident. And this is important because like when we do train a model, we don't explicitly record these feature names and the label names. They're more of just lists of numbers that go in. So the model will not store these feature names. So I think it's a good idea for us to store it in a JSON file. You can also see the average error metric here and the standard deviation. And this is what we get when we use the cross-validation scoring. If we were to use the train test split, then it would contain the RMSE and it will contain the MAE instead. And then if we want to access this model, we can use Flask routes. Flask is deployed here, and the route is XGBoost. So if you want to make a prediction, you can do something similar to this, where you just curl the route and then you pass it in a JSON, and in it you have the desired prediction. The key is desired prediction, and the value will be a list of the values for each of the features which you want to predict. And when you curl, it'll return a JSON containing the model information, like the feature names, label names, average MAE, and then it'll return your prediction as well for that label. So in this case, I pass in 3 values representing the IRQ metrics, and the prediction I get back is the predicted value for total package power. So that concludes the demo, very quick demo. So just to go over some of the future plans of the model server, and also if there are any additional questions, feel free to ask. So currently we don't have that many models set up. For now, this is just the standalone model pipeline for node level package power. In the future, we want to also replace some of the gradient boosting regression models and set them up with XGBoost instead. And also we want to set up models, since this is only node level, we also want to set up models that can predict per container package power. We also want to explore additional models apart from just XGBoost and linear regression, especially to train on non data. So we would like to explore whatever the other options are after we've fully set up the XGBoost pipeline. We would also like to update the linear regression models, since that's been no one's really been working on that for a very long time. It's most likely out of date. We also want to try and incorporate. So currently the models themselves are saved on in a bunch of different directories in Kepler model server. So we want to instead try to set up a separate repo, Kepler models, and we can have that instead store these initial models, and any newly trained models, we can try and merge them. One thing to note is that we do need to look into how we intend to merge these newly trained models, who gets to sort of make a PR to merge these models, how we're going to try and merge them, which models we select. We can probably select which models to use based on the error metrics that are provided. And that brings up like a second question, which is if I have certain error metrics, what kind of, what would be considered acceptable error levels? On a lesser, sort of not as important, would be to try and export the model weights in ways besides task. I think this was a pretty old task that was set up quite some time ago, but has been sort of neglected in the new development of the Kepler model server. So we want to try and export these model weights, not just with FastGraphs, but also maybe with Prometheus or OpenTelemetry. Probably the most important issue or task we want to work on right now is we want cleaner abstraction and more generalized base classes for implementing these new pipelines and models. So, the standalone pipeline inherits from an abstract class called train pipeline. And in all honesty, train pipeline is quite out of date. It's mainly designed for the Keras models, and it's generalized enough so that completely new models and pipelines we want to set up can't really use train pipeline, or a lot of the functions it implements aren't really relevant for XGBoost, since it was designed mainly for Keras. So we want to try and make it easier to implement these new pipelines with better documentation and have more generalized abstract classes. So that we don't feel like that some of the methods that are being implemented aren't actually useful at all or not relevant at all, and it makes the code a lot dirtier. So that pretty much wraps up future plans. Does anyone have any questions? I didn't check chat, so I should probably.
I think we're at of the hour, so this is all good information. The discussion is, I think there's a lot of questions about the model applications. So how good we can use the models on environments that we have not tested before. So that's one. I think there's a lot of going to be a lot of investigations, both in the deployment side and also in the research phase. And how can we ensure that the models is universally applicable? But I guess my gut feeling is that that's going to be the same question for all the machine learning or deep learning models when they are used in the environment that they are not trained for. How accurate can we trust the model?
Yeah. So
Right.
just to comment about that. So we cannot guarantee that, it will always work 100%, but we can show for a lot of different scenarios that we know it will work, isn't it? So we train with some micro benchmarks, for example, stressing different components of CPU, different resource. And then we validate with real applications. This will be different. And we need to guarantee that it will work for this set of applications that we selected. And then that will, again, stress different resource that we support. And this should be the validation. And this should be, fair enough to say the coverage of our method. But
Yeah.
again, we need to carefully select micro benchmark that stress everything that we think it's important, and representative applications, especially the ones that runs on cloud. No, I think the model shouldn't be workload specific. So the model should be architecture specific, different. We have Intel, AMD, IBM architecture, ARM architectures. This will change the model. Or even though if we have different components, we have GPUs, FPGAs, NATs, FPGAs in the machine. This might change a little bit also the energy consumption behavior of the machine, but the workload shouldn't decide different power models. The power model should be general enough to encompass all the kind of workloads.
I think I'm going to raise that as an issue so we don't forget. 'Cause that's probably an important task to take up after the pipeline's been set up properly.
All right, I think I have to go. This is a great time, so maybe you can follow the same format in the following meetings. So we get an idea exchange and certain presentations, and then we go through the progress next time.
Yeah, it was very good.
Right.
Thank you very well. Very
Thank
much.
you.
Thank you.
Thank you.
Thank you.
Bye-bye.